Hey guys, and welcome back to Study Journey. It's Mary and I'm back with another AMC 10 problem, and this is going to be a more advanced probability problem where it also involves arrangements to guess the probability. So without further ado, let's get on with the video. This is AMC 10A problem 17 of the year 2016. Let n be a positive multiple of 5. One red ball and n green balls are arranged in a line in random order. Let P of n be the probability that at least 3/5 of the green balls are on the same side of the red ball. Observe that P of 5 is equal to 1 and that P of n approaches 4/5 as n grows large. What is the sum of the digits of the least value of n such that P of n is less than 321 over 400? Your answers are 12, 14, 16, 18, and 20. So let's look at some keywords. It says that n is a positive multiple of 5. And there's one red ball and n green balls. So the total number of balls will be n plus 1. And it is arranged in a line in random order. So it says that P of n is the probability that at least 3/5 of the green balls are on the same side of the red ball. And that P of 5 equals 1, we'll talk about that later, and P of n approaches 4/5 as n grows larger. We'll talk about that too. So it is asking you what the sum of the digits of the least value of n is, such that P of n is less than 321 over 400. First, we would find the least value of n, and then we would add up the sum of the digits, and then that would be our answer. So why does it say that P of 5 is equal to 1? Well, here are 5 balls. Let's say that this is the 5 of the n, and n is equal to 5. So there are 5 green balls. Well, where can we put the one red ball so that there are at least 3/5 of the green balls on one side? Well, it doesn't say which side that there are 3/5 of the green balls. So if we put the red ball on the very side, then it would be 5 balls on one side. So that works. If we put it in between the first two, here's 4. If we put it in between these two, there's 3, and then so on for the same side. So P of 5 is equal to 1 because it doesn't matter where you put the ball. As long as you put it somewhere in here, the restrictions will apply to it. That's why the probability is 1 or 100%. Now it says that n is a positive multiple of 5. So n divided by 5 is a whole number. So we can divide it into 5 groups. Why are we doing this? Well, you'll see. Because we said that the P of 5 is 1, and the problem specifically brought this up to give you a hint. It is not there just for no reason. If we put n in 5 groups, so all this added together will be n. And let's let each group have n balls. And because we know that n is a positive multiple of 5, then these will all be whole numbers. And it would all be the same number. N is all the green balls. Now we have one red ball. And we are trying to put this one red ball into one of these groups or between one of these groups so that are at least 3/5 of the green balls on one side. Let's talk about the fact that P of n approaches 4/5 as n grows larger. Why is that? Well, let's give another example where n is not equal to 5. Let's let n equal 6. So there would be 6 green balls. And when we are putting in that one red ball, if we put it in the middle, then it would be 3 on each side, and that would be 1/2 on each side. So this spot would not work. And let's see, if we put it right here, it would be 2 on one side and 4 on the other side. So let's see if 4/6, which equals 2/3, is greater than 3/5. If it is, then it will work. If it doesn't, then it won't. So 3 times 3 is 9. We can cross multiply. 5 times 2 is 10. So 2/3 is greater than 3/5. So these two spots would both work. So when n equals 6, there will only be one spot where it wouldn't work. And so the probability that at least 3/5 of the green balls are on the same side of the red ball would be, well, you can put it here, 2, 3, 4, 5, 6, 7. There are a total of 7 spots that you can put it in. And there are only 6 spots that work. And 6/7 is in between 3/5 and 4/5. So you can see that as the number of n grows larger, then the probability will also grow larger, and it tells you towards 4/5. Now, we already know that the total number of green balls is now divided into 5 groups with equal numbers in each group. And when we are putting in this one red ball, since we know that P of 5 equals 1, if you put it anywhere in between these, it would work. So now, the only way it wouldn't be at least 3/5 on each side if the red ball was in the middle group. Because if it was in the middle group, let's say it's in the middle of the very middle, like if it was like this, then there would be a number that is less than 3/5 on one side. And so this is the only way where it does not match what the problem is asking. See, if you put it right here, there is already 3 big groups and 2 big groups. And since each group is the same on each side, then it would definitely work. Same for all the other spots. So let's look at the middle place. How many places of the numbers in n would this occur in? Remember, both sides of the group n will work. So let's just let n equal 3. This will be easy to look at. So if n equals 3, then each group has 3 balls. Let's let this be the middle group right here. And there will be the other balls on each side of it. So because if you put the ball right here, it will be the same as putting the ball right here. And this will have 3/5 on one side. Then if you put it on this side, it will also have 3/5 on one side. So these 2 places all work. The only places that wouldn't work would be right here and right here. So the total number right here, n, minus 1, would be the places of all the spaces minus these 2. So the number of spaces in between would be that number plus 1. So like right here, the number of spaces would be n plus 1. And then we do n plus 1, which is the number of spaces minus these 2 spaces. And then this will get you n minus 1. And that's how we got n minus 1. So n minus 1 will be the only place where it would not be counted in P of n. So now we can solve for P of n. Remember, P of n is equal to the probability that at least 3/5 of the green balls are on the same side of the red ball. Here is where it will not be. So if we get the whole probability, which is 1, and then minus the probability that this happens, won't we get the answer? This is when it won't happen, and then over the total number. Well, we know the total number is, like I said, n plus 1. The total number of green balls, and then you add that red ball. And then we already know that n is equal to n over 5. So right here, we can tell that small n is equal to the capital N divided by 5. Because remember, we got the total number of green balls, and then we divided it into 5 groups. Well, since the small n is equal to n divided by 5, then the big N would just equal 5n. Just multiply the 5 over. Now we can just substitute it. And then it asks what is the least value of n such that P of n is less than 321 over 400. Let's simplify it. Remember, we know that n is a whole positive number, so we can multiply it over. And look, 5n, that is a wonderful number. We know that n is equal to 5n. So we know that n is greater than 479. So the least value of n, such that P of n is less than 321 over 400, would be the smallest number of n, which is equal to 480. And that would be the answer to this. But remember, we're asking for the sum of the digits. So let's just add it up. 4 plus 8 plus 0. Easy. 12. And that's your answer. So looking at the answers, we can tell that the answer will be A, 12.